we see the application of derivative, increasing function and decreasing function. So what are the increasing function and decreasing function? We see in the last lecture. In this lecture we see some examples on the increasing and decreasing function. So it is a, what is the increasing? That is the strictly increasing and strictly decreasing function. Here f of x is any function, then f dash of x is greater than 0. That means it is a strictly increasing or monotonically increasing function. Okay, here it is monotonically increasing function, or f dash of x is greater or equal to 0. It is only increasing function. It is only increasing. Here f of x is any function, then f dash of x is greater than 0. It is a strictly increasing or monotonically increasing function. F dash of x is greater or equal to 0. It is only increasing function. Same for the decreasing function. Here f dash of x is less than 0. It is a monotonically decreasing or strictly decreasing. Okay, and f dash of x is less or equal to 0. It is only decreasing function. Okay, here in last lecture we see this, what is increasing and decreasing function, their geometrical interpretation of increasing and decreasing function. Okay, now we see the examples on the increasing and decreasing function. Here example is, find the value of x for which the following function is strictly increasing. Okay, it is a strictly increasing. F of x is equal to 3 plus 3x minus 3x square plus x cube. Okay, it is a given function. Now solution, it is given f of x is equal to 3 plus 3x minus 3x square plus x cube. Okay, therefore we find f dash of x. F dash of x is equal to, it is 0 plus 3 minus 6x and plus 3x square. Okay, therefore f dash of x is equal to, यातून उधून 3 कॉमन काढा. Therefore 3 कॉमन काढल्याच्यानंतर here x square minus 2x and plus 1. Okay, therefore f dash of x is equal to 3 into x minus 1 whole square. And here given that f of x is strictly increasing, f of x is strictly increasing. Okay, therefore we know that f dash of x greater than 0. Therefore 3 into x minus 1 whole square greater than 0. Now it is a greater than 0. Then this value x square, 3 into x square minus 1 whole square greater than 0. It is greater than 0 all values of real x except x is equal to 1. When we put x is equal to 1, it is 1 minus 1, it is 0. 0 is not greater than 0. Therefore here it is f dash of x greater than 0. Therefore f dash of x greater than 0 for all x belongs to real number except x is equal to 0. When x is not equal to 0, that means f of x is strictly increasing function when x is equal to, therefore you can write x belongs to all reals minus, it is x is equal to 1. Here f of x is increasing for all real values except 1, that is x belongs to real number, all real numbers except 1. Okay, now we see next example. find the value of x for which following function is strictly increasing. F of x is equal to 2x square minus 2x cube minus 3x square minus 12x plus 6. It is a given function. Now, given f of x is equal to 2x cube minus 3x square minus 12x plus 6. Here, given that f of x is strictly increasing here, and f of x is strictly increasing function. Therefore, you can write f dash of x greater than 0. Now, it is f of x. Now, f dash of x is equal to 6x square minus 6x. Okay, here derivative. It is x cubes are derivative 3x square, that is 6x square. Here 2x into 3, it is 6x and minus 12. Therefore 6 कॉमन जर काढलेत काय राहते x, it is x square minus x and it is 6 कॉमन काढल्यानंतर minus 2. Okay, then we can write here 6 into x minus 2 and x minus, it is plus 1. Okay, it is f dash of x. But here given f dash of x greater than 0, therefore this value greater than 0. Therefore 6 into x minus 2 and x plus 1 greater than 0. Okay, f dash of x greater than 0, therefore this value greater than 0. Okay, here. Okay, नाही लिहिले तरी चालते, it is given ही condition. That means x minus 2 into x plus 1 greater than 0. Now here greater than 0, it is an inequality. Okay, equality मध्ये आपण quadratic equation मध्ये factor पाहिलेले आहेत, either this bracket 0 or this bracket 0, but here inequality. Okay, it is a greater than 0. Okay, हेच factor जर असे असते, here x minus 2 and x plus 1 is equal to 0, then we can write here x minus 2 equal to 0 or x plus 1 equal to 0. Okay, here if it is a equality, now here inequality, x minus 2 and it is x plus 1 greater than 0. A greater than 0 means positive. Here the product of these two terms is 0, therefore either this 0 or either second 0, or both 0. Okay, here it is x minus 2 into x plus 1 is equal to 0. Okay, is equal to 0, therefore either this 0 or this 0, but here it is a greater than 0. Greater than 0 means positive. Okay, then the product of two terms is positive if both are positive or both are negative. That means here two cases, here x minus 2. Okay, here two cases, it is x minus 2 greater than 0 and x plus 1 greater than 0. Okay, both are positive, or x minus 2 less than 0 and x plus 1 less than 0. That means both are positive, then product is positive. If both are negative, that is the less than 0, then it is a product is positive. Therefore here for the inequality, and it is a product of two linear vectors. Okay, therefore the product of two linear factor, it is a greater than 0, therefore both are positive or both are negative. Okay, now here either x minus 2 greater than 0 and x plus 1 greater than 0, or x minus 2 less than 0 and x plus 1 less than 0. Here we have two cases, it is case 1 and it is case 2. Now here case 1, x minus 2 it is greater than 0 and x plus 1 greater than 0. Therefore we can write x greater than 2 and x is less than greater than minus 1. Okay, here we see the first case only, x both are positive, therefore both are greater than 0, therefore x minus 2 greater than 0, therefore x is equal to 2, x greater than 2, and here x greater than minus 1. But here x greater than minus 1, here x greater than minus 1 does not satisfy this condition, but x greater than minus 1 does not satisfy f dash of x greater than 0. Okay. Here if we take here for the real line, it is 0, it is minus 1, 1 and it is 2. Here x greater than 2 and x greater than minus 1. X greater than minus 1, that means it is x greater than minus 1, that means all the values, that is 0, 1, 2, 3 both are. If x is equal to 0, then here or here value could be put kara. Here when x is equal to 0, it is 0 minus 2, it is minus 2 and into plus 1, minus 2 plus 1 it is a minus 2, product negative value, but here product is greater than 0, that is positive. That means x greater than minus 1 does not satisfy this value, that is f dash greater than 0. Therefore we can write x greater than 2. Now case 2, it is x minus 2 less than 0 and x plus 1 less than 0, it is a case 2. Okay. Therefore we can write x less than 2 and x less than minus 1. X is less than 2 and x is less than minus 1. Now here 0, it is 1 and it is 2, minus 1, minus 2. When x is less than 2, when x is less than 2, that is x is equal to 1. When we put x is equal to 1, it is negative and it is positive, therefore product is negative. But we want to f dash of x greater than 0. Therefore f dash of x is less than 0 when x less than 2. And when x is less than minus 1, x is less than minus 1. Here less than minus 1 here. X is less than minus 1. When we put x is equal to minus 2, x is equal to minus 2, it is minus and it is minus 2 plus 1, again it is minus, minus, it is greater than 0, therefore f dash of x greater than 0. And here f dash of x greater than 0 satisfy this condition not satisfy. But here x less than 2 does not satisfy f dash of x greater than 0. Therefore we can write x less than minus 1, and therefore x less than minus 1 and x greater than 2 are the value of x less than minus 1 and x greater than minus 2 are the values of it is x. Here 0, it is 1 and it is 2, minus 1, minus 2. X is greater than, now these values दोन पेक्षा मोठा, x is greater than, and here x is less than minus 1, it is x is less than minus 1, no it is minus infinity and here it is infinity. Okay. X is less than minus 1 and x is greater than 2 are the values of x. Okay. Now we see the next example. Here we take strictly decreasing function. Okay, see carefully. f of x is strictly decreasing. Okay, decreasing means f dash of x less than 0, therefore it is less than 0, that is f dash of x. Yeah, same example, फक्त sign change झाले. It is strictly decreasing, therefore less than 0. Then it is less than 0. Then now here the condition. Product of two linear factor, it is a less than 0, that is negative. Product negative, it is x minus 2 and it is x plus 1 less than 0. Product is less than 0, that is product is negative. Product negative, it is either one is positive and one negative. If either this is positive, this is negative. When this is negative, it is positive. That means when x minus 2, it is greater than 0, x plus 1 less than 0. One positive and one negative, then product is less than 0. Or second condition, x minus 2, it is less than 0, it is negative and it is positive. X plus 1, it is greater than 0. Okay, here product is negative, therefore one is positive and one is negative. Okay, opposite signs, it is positive, it is negative, or it is negative, it is positive. Then when first case it is positive, then it is negative. Or इथं पॉझिटिव्ह याला घेतलं, आता याला निगेटिव्ह का, then it is positive. Right. These two cases. Okay, now we see case 1. Here x minus 2 greater than 0 and x plus 1 less than 0. Okay, here it is the third example, decreasing function. Therefore we can write it is x greater than 2 and it is x less than minus 1. Now here x is greater than 2 and x is less than minus 1. X greater than 2. Okay, x greater than 2, 0, 1, 2, it is 3, minus 1, minus 2 and it is minus 3. When x greater than 2 means 3, 4, 5, 6, they are still there. Okay, when x greater than 2, it is 3. Okay, 3 minus 2, it is positive and it is also positive. Okay, therefore it is less than 0. Okay, here it is positive, then product is positive, but it is less than 0. Therefore this x greater than 2 does not satisfy f dash of x less than 0. X greater than 2 and then x less than minus 1. X less than minus 1 means minus 2, minus 3, minus 4. When we put x less than minus 1, that is minus 2. When we put here minus 2, it is minus 2, minus minus, it is minus and it is minus. Therefore minus 2, it is minus 4 and but it is minus. Both are minus. Therefore here see carefully, both are minus, therefore it is also positive. That means x less than minus 1 also does not satisfy. That means both are does not satisfy f dash of x greater than 0. Here see carefully, when we put x greater than 0, that is 3, 4, 5, 6. When we put x is equal to 3 in this, x is equal to 3 put केलं, so it is positive and it is positive, but product is negative. Therefore x equal to 3 does not satisfy. Therefore this condition does not satisfy. Then x less than minus 1. X is less than minus 1. It is minus 2, minus 3, minus 4 up to minus infinity. It is when we put x is equal to minus 2. Here minus 2, it is minus 4 and minus 2 plus 1, it is minus 1. Minus 1, minus 4, product positive, but it is less than 0, that is negative. Therefore these two cases does not satisfy f dash of x less than 0. Okay, now here x greater than 0 and x less than minus 1 does not satisfy f dash of x less than 0. Now case 2. X minus 2 less than 0 and x plus 1 greater than 0. Therefore we can write x less than 2 and it is x greater than minus 1. Here now it is 0, 1, 2, 3, 4, it is a real line, minus 1, minus 2, it is minus 3. When we put x less than 2, x less than 2, okay, when we put x is equal to 1, when we put x is equal to 1, it is 1, that is negative, and it is positive, product is negative. When x is equal to 0, it is negative, positive, product is negative. But when x is equal to minus 1, minus 1, it is minus 3 and it is 0, then product is 0, but we want to product less than 0. Then x less than 2, but it is greater than minus 1. X is less than 2 but greater than minus 1. Now here, that is x is greater than minus 1, minus 1 less than x and less than 2. That means x belongs to only open interval minus 1 comma 2. Okay, म्हणजे x greater than minus 1 म्हणजे minus 1 पेक्षा मोठा पण 2 पेक्षा लहान. Okay, it is greater than minus 2, greater than minus 1 but less than 2. Here x is decreasing in the interval minus 1 to 2. X is decreasing in the interval minus 1 to 2. Okay, it is the value of x. X belongs to minus 1 to 2. When f dash of x is less than 0, that is f of x is strictly decreasing. Okay, now we see next example. F of x is equal to x plus 25 by x. Here f of x is equal to x plus 25 by x. Now f of x is strictly decreasing, therefore f dash of x less than 0. Now we find the derivative of f of x. Therefore f dash of x is equal to 1 minus 25 by x square. That is f dash of x is equal to x square minus 25 by x square. Okay, here x plus 25 by x, it is x is not equal to 0, there it is a condition. Then here f dash of x less than 0, therefore you can write x square minus 25 upon x square less than 0, therefore we can write x square minus 25 less than 0. Okay, हे 0 इकडे when x is not equal to 0. X is not equal to 0, x इकडे येऊन 0 लिहिला. Then here x square minus 25, therefore x square is equal, less than 25, therefore x less than plus or minus 5. X is less than plus or minus 5, and then this can be written as it is x less than 5 and x greater than minus 5. Okay, here निगेटिव्ह व्हॅल्यू साठी इनइक्वॅलिटी मध्ये साइन चेंज होणार, इक्वॅलिटी मध्ये साइन चेंज होत नाही, दोन्ही साइडला मायनस न मल्टिप्लाय केल्यावर. बट हियर व्हेन इट इज 6 is greater than 8 throughout multiplying by minus, here minus 6 and it is minus 8, but here it is 8. Okay, when a equal to b, both side multiply by minus. Okay, it is equal to, does not change sign, but here 6 less than 8 but multiply by minus, minus 6 minus 8, here sign change. मग here positive value साठी जे आहे ते sign ल्या. Okay, as it is, but the negative value here less than replaced by it is a greater than. That means here x is less than 5 and x is greater than minus 5. Here x is less than 5, it is x less than 5 and x is greater than minus 5. That means we can write minus 5 less than x less than 5, and that means x belongs to minus 5 to 5. X belongs to minus 5 to 5. Okay, here. Therefore, we can write x minus 5 less than x less than 5. That is, x belongs to minus 5 to 5 except 0. Okay, in the interval minus 5 to 5 there is a 0, but except 0, x belongs to minus 5 to 5. It is a strictly decreasing function. Okay, see carefully.